everybody. This is Indira, Institute of Aeronautical Engineering, Department of Mathematics. Today we are going to solve the problems of non-homogeneous differential equations. Now, before going to the method of non-homogeneous differential, before going to the problems of solving non-homogeneous differential equations, we'll slightly refer what is the methods of finding out and what are the things that we need to find calculate to solve the non-homogeneous differential equations. Generally, in this we have discussed in the previous session. The general form of the non-homogeneous differential equation is f of d into y is equal to q of x. Now, we need to find out two things, that is the complementary function and particular integral. Complementary function and particular integral. Complementary function, it is represented by yc, and particular integral, it is represented by yp. It is represented by yp. And the general equation of the non-homogeneous differential equations is given by yc plus yp. Now, to get the complementary function, we have to equate the auxiliary equation to 0. So, how to get the auxiliary equation? The auxiliary equation is obtained by replacing the d by dx. The d by dx, that which we are representing it as d, it has to be converted in terms of m, so that we will get the polynomial equation in terms of m, and that polynomial equation has to be solved for the values, and the number of the values will be based on the degree of the polynomial equation, and these values will give rise to the complement to write the complementary function for the given non-homogeneous equations. Now, based on these values may be real, complex, and sometimes Schurz also. And real, sometimes they are real repeated, sometimes complex repeated, and there are 5 varieties of methods of writing the complementary function for the given differential equations, and all this we have referred in the last classes. Now, let us go with one example. I have a simple example. I have taken a simple example here. Solve a homogeneous differential equation. Now, again, the question arises when the equation is said to be homogeneous. When this q of x is equal to 0, there is no need to find out the particular integral. We need to find out only the complementary function. So, it is called as a homogeneous differential equation. If q of x is not equal to 0, then we need to find out the particular integral also. So, given the equation is in the form of f of d into y is equal to 0. So, f of d is nothing but d cube minus 3d plus 2 is equal to 0. So, the auxiliary equation is obtained by f of m is equal to 0, and f of m is equal to m cube minus 3m plus 2 is equal to 0. Upon solving this third degree equation, we are factorizing, we are going to get as m minus 1, and m plus 2 is equal to 0. That means m takes 1, 1, minus 2. And 1, 1, minus 2 are the real values, are all real values. How to frame the complementary function for these real values in which one of the root is repeated, that is 1, and the third root is not repeated. So, it can suppose if alpha, beta is my roots, then the complementary function is given by c1 plus c2x e to the power of alpha x plus c3 e to the power of beta x. So, this is how we can give the complementary function following the same method here. C1 plus c2x into e to the power of x, e to the power of alpha x. Alpha is nothing but 1 here, plus c3 e power minus 2x. Remember that the number of constants that are framing is equal to the order of that given differential equation. The order of the differential equation is 3. Order is 3. Therefore, the number of constants that you should get in the complementary function should be 3. Otherwise, the answer is wrong. So, this is how we can solve this homogeneous differential equation. Now, similarly, we will go for the next homogeneous equations. Solve d to the power of 4 minus 2d cube minus 3d square plus 4d plus 4 into y is equal to 0. f of given f of d is equal to d to the power of 4 minus 2d cube minus 3d square plus 4d plus 4 into y is equal to 0. Now, an equation, the framing the auxiliary equation, we will get m to the power of 4 minus 2m cube minus 3m square plus 4m plus 4 is equal to 0. This is obtained by replacing the given derivative with m, that is a constant. Because d is an operator, we can't get the polynomial equation in terms of an operator. So therefore, we are converting in terms of the variables to get the polynomial equation. So here, this can be factorized. And which I got it as m plus 1 whole square into m minus 2 whole square is equal to 0. So m is equal to minus 1, minus 1, minus 2, minus 1, minus 1, 2, comma 2. So here two roots are repeated twice, that is minus 1 and 2, comma 2. So when this type of roots are there, then the equation can be, for suppose if I have and roots as alpha, alpha, beta, beta, whatever may be the alpha and beta, that is a real roots, then it can be written as c1 plus c2x e to the power of alpha x plus c3 plus c4 x e to the power of beta x. So this is how we can give the complementary function. So the complementary function for this question is yc is equal to c1 plus c2x e power minus x plus c3 plus c4x e power 2x. We don't have the particular integral because the q of x value is equal to 0. So the general solution is just nothing but the complementary function, that is yc. So this is how we can find it out. Now let's go for the next equation. Solve the differential equation d square plus 5d plus 6 into y is equal to e power x. I have taken the simple non-homogeneous differential equation. Why I said that it is a non-homogeneous differential equation? Because the given equation is in the form of f of d into y is equal to e power x. It is in the form of f of d into y is equal to e power x. So it can be here q of x is equal to e power x. So the auxiliary equation is f of m is equal to, replacing d by m. We will get the auxiliary equation, that is the second degree polynomial equation, m square plus 5m plus 6 is equal to 0. So m square plus, if you factorize this, we are going to get it as m square plus 3m plus 2m plus 6 is equal to 0. Upon factorizing, m plus 2 into m plus 3 is equal to 0. So therefore, m bears the value minus 2 and minus 3. So we have got only two equations because the order of the differential equation is 2. So order is 2, therefore the number of the real roots m also is equal to 2. So therefore, how to find, then these two are real values, minus 2 and minus 3 are the real numbers. So how to get the yc value, that is c1 e to the power of minus 2x plus c2 e to the power of minus 3x. So this is how we can give the complementary function. So the roots are real and distinct, therefore the complementary function is given by yc is equal to c1 e to the power of minus 2x plus c2 e to the power of minus 3x. Remember that solving higher order differential equations is very easy compared to first order differential equations, because in higher order differential equations only two terms we need to find it out, that is complementary function and the particular integral, and we have only few cases for finding out the particular integral, that is exponential, binomial, trigonometrical, and combination of these three. So therefore it becomes very easy to catch the method easily. And let's go for the next step of the problem, that is finding out the particular integral. Now how to find out the particular integral? Yp is given by 1 by f of d into q of x. 1 by f of d into q of x. We have got only the complementary function. Now we have to find out the particular integral also. So 1 by f of t into q of x, and which comes out to be 1 by d square plus 5d plus 6 into e power x. And again factorizing 1 by d plus 2 into d plus 3 into e power x. So put d is equal to 1. So the particular integral, because the coefficient of x is e power x, the coefficient of e power x is 1. So we have to substitute d is equal to 1. If d is equal to 1, the particular integral is given by 1 by 3 into 4 e power x, that is 1 by 12 e power x. If suppose upon substituting d is equal to 1, if you are getting 0, then numerator it has to be multiplied with x, and the denominator we have to take the derivative form. So the process can be continued till you get the non-zero number. So like that but here in the question we got non-zero number direct itself, so there is no need to multiply the numerator with x, and here I got x 1 by 12 e power x. Now the general solution is a combination of two, that is a complementary function and particular integral. So complementary function I got it as c1 e power minus 2x and plus c2 e to the power of minus 3x plus e power x by 12. So y of x can be written as c1 e to the power of minus 2x. Y is nothing but y of x. c2 e to the power of minus 3x plus e power x by 12. So this is how we can find out the complementary general solution for the non-homogeneous differential equation. Now let's go for the next differential equation, solving d square plus 9 into y is equal to cos 3x. I have taken an example of trigonometrical function here. This is one of the non-homogeneous differential equation. So the two parts we need to find it out, that is complementary function and the particular integral. So obviously as usually the complementary function is obtained by replacing d by the constant, that is m. So I'll get it as m square plus 9 is equal to 0, or m is equal to plus or minus 3i, and in this case I got the complex value as a root. Therefore the complementary function is given by c1 cos 3x plus c2 sine 3x. Whenever you will get a complex number as a root, complex roots always appear in the conjugate. Suppose alpha plus or minus I beta is a root, then yc is given by e to the power of alpha x c1 cos beta x plus c2 sine beta x. These are all we have finished in the last sessions when we are discussing about the higher order differential equations. Here in this one, alpha is equal to 0. We don't have the real part of the complex number, and the imaginary part beta is given by 3. So therefore I can frame the complex function as c1 cos 3x plus c2 sine 3x. So yp, now complementary function I have finished. Now going to the particular integral. If you go for the particular integral, cos 3x by d square plus 9 or cos 3x by d square plus 3 square. Now I'll substitute. I have a formula that cos ax by d square plus a square is nothing but x by 2a into sine ax. So this is it. Here a is equal to 3. So I got it as x by 2 into 3 sine 3x is equal to x by 6 sine 3x. So this is a particular integral. Again, the same thing. The general solution of the given non-homogeneous differential equations is given by the complementary function of the particular integral, and the complementary function is c1 cos 3x plus c2 sine 3x plus x by 6 sine 3x is a general solution of this non-homogeneous differential equations. So similarly, one more problem is there. Here I have taken a binomial term, that is 1 minus 4x cube y triple dash, that is this can be written as d cube minus plus 2d square minus d minus 2 into y is equal to 1 minus 4x cube is a question. So auxiliary equation is m cube plus 2m square minus m minus 2 is equal to 0. The first part, this is used to find out the complementary function, and upon factorizing and solving I got the values as 1 minus 2. All the three roots are real here. So here all the three roots are distinct and real. So just like alpha, beta, gamma, which is nothing but c1 e to the power of alpha x plus c2 e to the power of beta x plus c3 e to the power of gamma x. So see, complementary function is given by c1 e to the power of x plus c2 e to the power of minus x plus c3 e to the power of minus 2x. Now, upon going to the particular integral, it is not just nothing but the formula 1 by f of d into q of x. So 1 by f of d is nothing but 1 by dq plus 2d square minus d minus 2 into q of x is 1 by 4x cube. Now I'll try to expand this binomially by taking 2 as common. So the minus 1 by 2 into 1 minus dq plus 2d square minus d by 2 into 1 minus 4x. So bring this on the numerator and use the formula as 1 minus x whole to the power of minus 1, which is equal to 1 plus x square, so on up till infinity. So I got this value, and this upon 1 by 1 term has to be multiplied with 1 minus 4x cube, and wherever d is there, you have to differentiate it. So 1 minus 4x cube has limited number of derivatives, only limited terms we are going to get it out. So the answer that can be given as minus 1 by 2, 1 plus this can be written as minus 1 by 2, 4x cube plus 6x square minus 30x plus 16, and which comes out to be 2x cube minus 3x square plus 15x minus 8 is 8. So taking the derivatives of each and every function, we are going to get this value. So again, the general solution is given by the complementary function plus particular integral, that is c1 e to the power of x plus c2 e to the power of minus x plus c3 e to the power of minus 2x plus 2x cube minus 3x square plus 15x minus 8. So this is how the non-homogeneous equations for different cases, that is e power x, trigonometrical function sin x or cos x, and binomial terms, that is for 1 x to the power of n, can be found out. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.